Good morning, students. Welcome in Natural Language Processing class. Today we will cover first two chapters of the book, Hands-on Python Natural Language Processing by Aman, Kedia and Mayank, Rasu. Natural Language Processing or NLP is the specialization branch of artificial intelligence that allows computers to understand, interpret and generate human language in a way that is both meaningful and useful. It serves as a bridge between the way humans communicate and the way machines process data, drawing from the different fields like linguistics, computer science, and statistics. The ultimate goal for any NLP system is to pass the Turing test, a benchmark where machines' conversations is indistinguishable from humans. The primary reason NLP is difficult is the massive gap between programming languages and natural languages. Programming languages are deterministic and follow some strict rules, whereas the human language it is evolved over thousands of years. For humans, it is easy to understand the context of any language, but for the machine, it is difficult to understand that what the actual context is. Well, the importance of NLP is skyrocketing because AI is projected to create between 200 to 500 million jobs by 2030. Learning NLP today places you at the center of this massive global shift in the labor market, making it one of the most valuable skills in the tech. The industry is currently seeing a gold rush of startups that are solving real world problems. The bigger giant companies, tech giants like Samsung and Reliance are aggressively acquiring these startups. There is a clear path from learning these skills to working in high growth environments. In our current era, chatbots are the most visible applications of NLP, with the market growth from 17 billion to over 100 billion by 2025. These bots are moving from simple if-then scripts to sophisticated conversational agents that can handle complex customer service tasks. As we look to the future, we are moving towards models like BERT, bidirectional encoder representations from transformers, which was developed by Google. Unlike older models that read text left to right, BERT reads the entire sentence at once to understand the full context of every word. So this is some basics about the NLP. Now coming towards the practical aspect of NLP, that is the second chapter. You have to practice these exercises and the code which I have provided on the website in Google Colab. The Google Colab basically provides a ready to use Python environment and it can run directly into your browser without needing to install any additional software. First, open a new notebook in Google Colab and locate the file icon in the left sidebar to find the content folder. You need to upload the file which I have provided, flight_data.csv, into the content folder before running this script. So we are starting with the real world problem using a dataset from the US Department of Transportation that contains over 500,000 flight records. The goal is to find which airport had the longest average departure delays. So we use the pandas library for this because it is designed to handle massive tables of data efficiently. So by writing a short script to group the flights by their origin and calculating the average delay, the code reveals that the Pago Pago International Airport PPG had the highest average. In this next example, that is a vectorization process because the computer acts as a translator, converting human language into a language of numbers that machines can mathematically manipulate. Because algorithms cannot read words or understand their sentences directly, they rely on matrices to represent the structure and content of a sentence. So, how we can transform our sentences into matrices? Uh, let's suppose we take an example how to change a payment method. So, we want to convert into a numerical vector. The computer can then apply linear algebra and logic to compare that sentences to thousands of others, identifying patterns or similarities that would be impossible to detect through raw text alone. So we will use here a count vectorizer function, and we will also import count vector from sklearn feature extraction library. Tokenization is the critical first step in NLP, where a continuous string of text is sliced into discrete, manageable units called tokens. As shown in the provided code, the NLTK library uses the word tokenize function to break down a complex sentence into a smaller units. The noise reduction via stop word removal is a refinement stage in NLP, where common grammatical glue words such as and, or are filtered out because they carry very little semantic weight. By using the NLTK library to download and apply the English stop word list, the system can strip away these frequent but uninformative words. Lemmatization is a sophisticated normalization technique that performs a vocabulary lookup to resolve different forms of a word back to its dictionary base or lemma. As illustrated in this slide, using the WordNet lemmatizer from the NLTK library allows the system to recognize different words and their roots, like programs is simplified into program and the sentiments is simplified towards sentiment. Syntactic analysis, specifically part of speech tagging, is the process of labeling each word in a sentence with its corresponding grammatical category, such as noun, verbs, and adjectives. We use nltk.pos tag function to analyze a sentence where the algorithm identifies bold as a noun and fastest as a superlative adjectives. Basic sentiment analysis using the text blob library provides a straightforward out of the box API for quantifying the emotional tone of a text. As shown in this slide, the system evaluates phrases to produce two key metrics: polarity and subjectivity. Polarity measures the emotional charge of the statement on a scale from -1 to 1, where -1 indicate a highly negative sentiment, as seen with the phrase "what a terrible thing to say," and 1 represent a highly positive sentiment. Alright, let's mix things up. We have seen how to analyze English, but the world is much bigger than a single language. In this slide, we will see that how we can translate different kind of sentences by using the deep translator and text blob libraries. Think of this as the universal translator movement for our code. By leveraging the Google Translator module, we can take a single English thought and instantly teleport it into French, Chinese, or Hindi. This is not just about changing words, it is about localized data extraction, taking information from one corner of the globe and preparing it for our end. Now let's learn Python script designed for web scraping to collect data from different e-commerce platforms. By using libraries like Beautiful Soap and Pandas, the code identifies specific product details such as name, cost, and customer ratings. The process involves targeting a specific URL and parsing the HTML structures to extract relevant information into an organized format. Once the data is gathered, the script converts it into structured data frame for easy viewing finally, the program concludes by exporting the results into a CSV file, providing a practical example of automated data retrieval. If you have any kind of issue, on Wednesday we will have a Zoom meeting and we will discuss if you have any questions related to your assignments. Thank you.